There we go. Okay. All right, so let's start with that one. So yesterday we saw the graphs, right? Now we're flying the plane blind. We can't look out the window. We got to rely on the instruments alone. That's what's going on, right? We're learning to be able just to look at an equation or an inequality, x to the fourth greater than 1, and figure out where that's going to be true. How do we do it? So remember the steps I gave you? I mean, if we had the picture, that would make it easy. But we basically do the things that we would do if we had the picture, right? Well, that's not exactly said right, but you know what I mean. Step 1 is you've got to get a 0 on one side, right? So that would be x to the fourth minus 1 greater than 0. Right? So step 1, you've got to get a 0, because it's all about whether it's greater than 0 above the x-axis or less than 0 below the x-axis. We're kind of picturing the picture even though it's not there. We're imagining what these instruments are telling us about the picture, like when you fly the plane, right? So, right, if you fly blind, you look at the instruments, imagining what they're telling you, especially the altimeter, about how high you are off the ground, right? So that's kind of what we're trying to do with these steps. In step 2, we're supposed to solve the equals 0 version. Basically find out what makes it equal 0. So how am I going to take x to the fourth minus 1 greater than 0? Find out what makes it equal 0. Yeah, you can factor, you can fourth root it, whatever you want to do. So here, I'll just make it equal. So there's step 1, here's step 2. Make it equals, bump the 1 to the other side. X to the fourth is 1. Then do the fourth root thing. Like that. Or you could have factored it too. That would have been okay too. You know. And then that's going to be, when you put an even root, when you put roof on the house, up and down the ladder. Yeah, plus or minus 1, right? My goofy saying, it's gonna serve you well. Roof on the house, up and down the ladder. All right, plus or minus 1. Same thing you'd get if you factored it all out. So, okay, step 3, remember number line? So then you take those answers that you just got, -1 and +1, and you put them on the number line. So that's like taking a stick, you know, and cutting it in 2 places. Now we have 3 sections, right? We always have one more section that we do breaks, right? So 2 breaks, 3 sections. So basically it's about finding out, is the graph, without actually seeing the graph, is the graph above or below in the left section? Is it above or below in the middle section? Is it above or below in the right section? Right? So that's what we want to figure out. Where is it above? Where is it below? Because basically we're being asked to find where is that thing greater than 0, which means above, doesn't it? Greater than 0 is above. So I want to find out, like maybe in the middle it's above, or maybe over here in the left it's above. I don't know. We got to figure that out. So there's a couple of ways I gave you to figure it out. Hey, are either of these points vertical asymptotes? No, we don't even have a fraction. You only get verticals when you got a fraction in denominator 0. Makes your vertical asymptotes, huh? So we don't have any of that. So we can just do the end behavior. Like what is the graph doing over here in the end? And then kind of work our way backwards to with the bounce pass through stuff, right? So what's this graph doing in the end? What's his end behavior? The end behavior? Is it? What is it? Remember what end behavior is? Most powerful term, right? The highest power term. So we just say y equals positive x. I just grab that most powerful term. I don't care about the -1. Because the most powerful term will take over eventually, huh? He'll dictate, in the end. In the end, when you're plugging in 1,000 and a million, the most powerful term will dominate the scene. So positive x to the fourth, so that means it's going up, up, up in the end, isn't it? It's positive end behavior. So then now we just got to figure out if the +1 and the -1 are bounce or pass-through points. Now, how do we figure that out? Seth?
If it was negative x4, then it would go down?
Yes, exactly. So if that was a negative x to the fourth, then the graph would go down. Right? Everybody good with that? That's exactly it. The end behavior tells you up or down based on the sign of the most powerful term. Exactly. All All right, so we're gonna, to determine the bounce, like is this a bounce, a boing, or is it a pass-through? How do we figure that out? Got to factor. Probably I should have just factored from the beginning. Huh? I was trying to save some time, didn't work out.
Actually,
So
because the x equals 1 and negative 1, those are multiplicity of 1.
how do you know?
Well, because it's x equals 1, so in order for it to equal 1, that means your factor must have been x minus 1. And
How do you know it wasn't x minus 1 squared? See, that would still be 1. So we can't know. We got to factor. So we got to factor to be sure. So so x squared plus 1, x squared minus 1, right? I don't know if that's a good place to factor. I'm kind of running out of room here. Let me just go over here. So x to the 4th minus 1 factors as x squared plus 1, x squared minus 1, right? And then this one will go further. The plus will not, as I've said several times. Double, double, plus, right? Can't, XX, 1, 1, double, double. I call it with a plus. Can't do it. So that just stays x squared plus 1. But the other one will break down to x plus 1, x minus 1. So there is the complete, I can't hardly read that, can you? Complete factoring, there. Complete factoring of the thing. So, all right, so where's our minus 1 is just there, right? First power, and the plus 1 is there, first power. It's the opposite side of what's in the parentheses, right? So anyway, they're both just first power. They're both odd. So if they're both odd, then they're both passers through, aren't they? So it just passes through, passes through. Doesn't bounce. Bounce is only for an even power. Like if there was a 2 power on the x minus 1, that's actually positive 1. That would mean the plus 1 would bounce if that had an even power. Remember that? Even powers are bouncers. Odd powers are passers through. Right? Tim?
So you took the negative 1 from the x plus 1. Do you disregard the x squared plus 1?
Right. Tell me why. He's like, I don't know. Yeah, he's right. I disregard this completely. Why? Remember, because we were solving what equals 0. So tell me, how is this bad boy right here going to make anybody 0?
It doesn't.
Cannot do it, right? X squared, that's going to be positive. At 1, he ain't ever going to be 0. Yeah, so he is unable to make anybody 0. He does not produce any x-intercepts. Right? He doesn't lead to anything on the x-axis, right? Right? If you solved him, if you move the 1 over to be negative 1, you root both sides, you get imaginary. How about that way? That helps you. Whichever way you want to see it. He's never going to be 0, is he? Good question. But these guys, they both lead to somebody being 0. If x is negative 1, this piece is 0. If x is positive 1, this piece is 0. So they lead to those x-intercepts, and they're both first powers, so they're both passers through because they're odd powers. Odd multiplicity. So, all right, so what's the final question then? We're looking for where's it above? Greater than 0 was the original question. So where's it above? It's above in this section of the x-axis, because this is above, and this section of the x-axis, because this is above, huh? So what's that? Negative infinity to negative 1 and 1 to infinity. Is that good? Now, there's no solid bar. Look at the original question. It was just greater. It wasn't greater than or equal to. So when you don't have the bar, don't even think about brackets. No way any brackets are anywhere. Don't even need to give it a second thought. So negative infinity to negative 1, comma, or united with, I don't care, on the test, whichever, 1 to infinity. There's our answer. Good on that? That's making sense, this whole process? So we're basically kind of like doing the graph without doing the graph, huh? Kind of like casually figuring out where the graph is, just like a pilot does looking at the altimeter. He's thinking about the ground still, even though he can't look out the window, right? Is that good? Questions on that? So then the easy ones will seem easy. All right, let's try that one. So it's a fraction, so we know we're going to have verticals, huh? In fact, what's the vertical asymptote right now? Negative 3, whatever makes the bottom 0. There's going to be a vertical there, right? Now, remember what step 1 is, though. Remember the steps. Step 1 is what? Get a 0. And, I need to add to it, I should say. And make it one fraction. Remember how we had to do that before? Going to have to do that here. So your first step is going to be 3x minus 5 over x plus 3 minus 2 less than or equals to, bring that 2 over. So minus 2 less than or equal to 0. And then you have to put those together into one fraction, like we had to do in that other section, because all of our thinking is all in terms of one fraction. One numerator, one denominator. You can't have a fraction and then like a number. It just won't be consistent. So, all right, so what do you got to do? You got to combine these together to make them one fraction. You know how to do that, right? Put this over 1. You got a whole number interacting with a fraction, make it look like a fraction. And then you got to make common denominator, right? So go ahead and do that real quick. I think you'll get more out of it if you try first. So make those common denominator. So you got to multiply top and bottom of that 2 over 1 by x plus 3, right? Everybody good with that? So to come in here and go x plus 3, x plus 3. We good? Make those two denominators the same. So then what will we have? We'll have 3x minus 5 over x plus 3 minus, and this will distribute 2x plus 6 over x plus 3. Wrong way there. Greater than or equal to 0. Good so far? Now, if you want to save some time, you could just say, look, I'm just gonna let that minus. I kept them separate. Probably quicker just to do it all at once. Yeah. I mean, what I wrote is true, but it'd be quicker for you. I bet you're thinking, shouldn't we take a -2? Yeah. If you're going to make it all 1, do that. So in other words, let's just do that. That minus 2 will be minus 2x minus 6. It would have eventually, the way I had it also, because that minus in the middle, when I put them together, would have needed to distribute. But let's just do it all at once. Be easier. So you see how I made the 2 into one fraction now. That's one fraction. And watch how the minus, a lot of people forget to distribute that minus 2 to the 3. So see how it's a -6 there? That's the most common mistake in this kind of a problem, is that right there. There's number 1 on the charts. Is they'll get a +6 instead of a -6. Everybody good there? That good? And now just simplify, huh? 3x minus 2x is x. What's that? Minus 5 minus 6 minus 11. Like that? Now it's regular. Now we're like down to the norm. That's the way they normally start for us, huh? That's the way those last 3 problems, or 2 problems, I just skipped, started, huh? So let's do it forward from here. So that's step 1, getting a 0 and making it into one fraction. So now go ahead from there. What do we do now in step 2? It's numerator equal to 0 and denominator equal to 0, right? Because anything that makes the top 0 makes the whole fraction 0. Anything that makes the bottom 0 is x-intercept, asymptote. Not x-intercept, vertical asymptote line, huh? So that's pretty easy, right? X is 11, x is -3. Positive 11 and -3. Good there. So then step 3, put those on the number line. And make sure you put the one that's a vertical as a vertical. Who's the vertical? Asymptote. Yeah, the denominator. We identified that from the beginning. The -3. So really the only new thing is the 11, huh? Which turned up when we combined the 2 fractions. So go to the number line now, and you could do the end behavior. Go to another screen here. I'll flash back if you didn't get all that. So we're going to say x equals 11, and x equals -3 is the denom. This was from the numerator, right? Yeah, x equals 11 from the numerator, -3 from the denominator. Let me write down what we have. X minus 11 over x plus 3, less than or equal to 0. Okay, so we go to the step 3 is number line. Put those on the number line. So we got -3. and negative 3 is a vertical, and positive 11 is just a normal x-intercept, huh? We good there? So we know we're not going to touch the negative 3, because you never touch a vertical. Okay, so off to the right, shall we start with the end behavior? What's it doing at the end? Yeah, and you know what, as far as like what it's doing and stuff, it's going to be easiest just to always focus on this one now. I mean, you could go back to the first one, but it'll be a lot easier. We're just going to pretend that was the original problem now. You know, once you've got your 0 and you've got them combined, just go from, don't ever go back to anything before that. That's really what you want to work with. That'll be easiest to just work with that going forward. So just pretend that's the original question for all practical purposes. It's the same as the original question, just cleaned up version, easier for us to work with. So, okay. So what's the end behavior then? Oh, that's hard to tell when you got a big, well, no, it's not. We could do it. Yeah. What's the end behavior? X, remember, it's just most powerful term in the top, most powerful term in the bottom, because you go off to the right forever, plug in positive 1,000, positive 1,000,000. You know, it's just going to be most powerful, which is just positive 1. What that really means, it's going to level off with a horizontal asymptote at +1, but we don't care right now. I just say, hey, it's up. All I really care about right now is it above or below. I don't really care about particular asymptotes and stuff. That is what it means. You guys know well from previous work, that means it's a horizontal, it's going to level off at +1 at a horizontal asymptote. But all I care about is, hey, it's positive, right? So all I'm looking for right now is the sign, which means it's going up. It's going up and leveling off, but going up's all I care. Seth?
Can you show us an example of powers where it's not x equals x over x?
Yeah, good question. If it was like x to the third plus 7x squared plus, whatever, over x plus 9,000 or whatever. So I would just take most powerful term in the top, most powerful term in the bottom, x cubed over x. That reduced to be x squared. And what would that mean then? That's positive, so that would be up as well. So, okay, now what if it was, whoops, let me go over here. 7 minus 3x minus, let's go minus 3x squared plus 12x over 7x plus 4. All right? So what if I went off to the right forever with that? Most powerful. It's all that matters when you're plugging in thousands and millions is the most powerful. So that'd be minus 3x squared. The minus 3 matters because that's multiplied by the most powerful. So he's going to have a big effect. Over 7x, they would reduce. Minus 3x over 7, it's negative. So that would go down, wouldn't it? Does that make sense? So again, it's just most powerful on the top, most powerful on the bottom, like that. If it's positive, it's positive. If it's negative, it's negative. All right, so this one is in behavior positive. Now, what about 11? Now we can determine 11, is that a pass-through or is that a bouncer? First power, odd, so it's a pass-through. It's going to go like that, huh? Is that good? Now, when it comes to the asymptote line, right here. The asymptote lines, you never touch vertical asymptotes, huh? So I can't do the pass-through bounce thing for a vertical asymptote because it doesn't touch it. It neither passes through nor bounces. You can't touch it. So you can't pass through it. Right? It's got to skip over it, right? It can't bounce there because you can't touch it. So you can't do the pass-through bounce. That's only for normal x-intercepts that you can do the pass-through bounce, not at a vertical asymptote. So all I care about again, though, is above or below. Because they're asking me to find, what did they ask me to find below, huh? Less than or equal to 0. They're asking me, where's that thing below? So what do you think, guys? Could it come back up here and go above like that? Could it be going up in the middle section? No, because it would have to cross the axis again, and we know it doesn't. Or there would be another x-intercept there, and we already found all the x-intercepts. See how this information really, just finding a couple of key pieces of information with your skills, with these math skills, gives you a lot of information about what that graph is doing. We know it's got to be going like that, huh? It's got no other choice. It has to. It can't come up again or it would cross the x-axis. There'd be another x-intercept. No way. Now, over here, I have no idea. I'm going to have to plug something in. There's just no way to know. It could be down, could be up. It could do either one. Graphs could go either way. There's no easy way to know. So you just have to plug in a value. So over here, like what's something like -4? You know, something left of -3. -4, -5, -10,000. You know, whatever you want. Plug into what? Into this, huh? Into x minus 11 over x plus 3. Plug in the -4. So what do you get? -4 minus 11, -4 plus 3. Remember, all I care about is sign. -15 over -1, that's positive. So that means it's up here, isn't it? It's positive. It's up in that section. And there's no way it could also come down, right? There's no way it could also cross down because there'd be another x-intercept, and there's not. So it must always be above the x-axis up here. I don't know if it really levels off, make go back up. I don't know. All I know is it's always above. All right, I'm ready to answer. So we kind of got a rough sketch of the graph, don't we? A rough feel. Certainly we have exact knowledge of where it's above and where it's below. All right, so they want below. They want less than or equal to 0. Where's it below? Here, huh? Only here, which means it's from here to here on the x-axis. From -3 to 11. Now, did we put any brackets on anything? Yeah, they had a less than or equal. When they have the equals, the bar leads to brackets, BB. When they have the bar, you'd like to put brackets. But you can't put brackets at a vertical asymptote line. Right? So -3 still sticks with a parenthesis because you can't touch that. But you do put a bracket on the 11, huh? And that's our answer. Yeah.
Didn't you just determine that it was
Rania.
yeah.
Which question?
Didn't you determine that it was in the above the x-axis just because it's an asymptote and it's not to the same power? So that the opposite. Does that make sense?
Yeah, I hear you. Maybe.
And then if it was the square, then you know it would be next to each other.
Right. Yeah, maybe. Right, because no, okay, I'm thinking it out with you. No, because so when I have a question like that, here's what I do, rather than just tell you the answer. Because in math and science, it's not about memorizing all the answers. It's about learning to figure it out for yourself. So as you were saying that, Ronnie, I was looking and going, maybe you're right, because I don't have it all memorized. I don't think any math teacher does, or science teacher. But what I was doing is I was running numbers. I go, is that true? I was trying out different things, and I thought about this. I thought, what if they reversed that and made that 3 minus x on the bottom? And I thought, and then what if I plugged in that -4, right? Because you were saying, if it's x over x, it's always going to be diagonal like that. But you see, then that would be -3 plus 4, positive. It would actually be down now, wouldn't it? So no, we can't rely upon that. So just test things. That's it. That's what math science people do. They test their philosophies and with numbers. Good question. All right, so we'll just have to plug in a number to be sure. So around asymptotes, you just have to plug in a number. See if it's above or below. There's probably other fancier rules that would tell you, but they're probably just as hard as plugging in a number, honestly. Tim?
Did you say that wouldn't work again?
Why did you say it wouldn't?
Yeah, how did you explain that it wouldn't?
I just plugged in, I just changed the version of that. So I just said it's x's over, I just turned it around to be 3 minus x. So when it's x's over x's still, but I plugged in -4, and it was actually down here. It was negative on that, so it wasn't above. So these were not diagonal necessarily. Now you can extend it and go, yeah, okay, but so then if one of them's negative, then it's going to probably, yeah. You're getting so complex at that point. Because what if the one on the top's also negative? What if one's negative? It's getting so complex, you just plug in a point. So at some point, the rules get so complex that it's really not worth it to memorize such complex rules on that.
But if you change the bottom to, you made it
The other side would
3
be-
minus 6.
Uh-huh.
So then the you said 3 minus 6. Never mind. asymptote would change from positive to
All right, William.
Wouldn't if you change the bottom, it change the part of the graph on the other side of the asymptote as well?
Oh yeah. Oh, so maybe they are both together, huh? Yeah. I think you're right. Yeah. You guys are probably onto something. I don't got time for it. Be glad to help you downstairs. I research it thoroughly with you. All right, let's try this one. All right, so you know the first step. In fact, I want to just do like the first step or two because of time. So, what's the first step? Get a 0. So pop that 9 over 8x minus 7, jump it over, right? And then you got to combine them into one fraction, which means what? Algebra, right? Which is the reason people don't pass calculus. It's not calculus, it's algebra. So here's and there's the man that'll help you with algebra. Mr. Roberto. And me too, from the upstairs. Anyways, this is important, this really matters. See how your algebra is right now. Do you remember how to combine those? Bring that over and combine those. Okay, so step 1, get a 0 and make it one fraction, right? So it's going to be 6 over x minus 9 minus 9 over 8x minus 7 greater than 0. Is that good so far? Now we've got to combine those into one fraction. Watch your signs closely. All right, so multiply top and bottom. You got to basically multiply by the other guy, right? So multiply top and bottom of this one by 8x minus 7. Top and bottom of that one by x minus 9. You with me? That'll make the two denominators have the same two things now and be common. Remember that from algebra? So you got to multiply by the other denominator, basically, right? And then FOIL those out and combine. Watch your signs. Remember, you know what I would do, guys? I would take that minus right there and put it on the 9 right now. That's the number one mistake. People will forget that that's really a minus 9. Remember a minus in front of a fraction? You can put it on the top only, or a lot of people asked, not a lot, a few people asked me about that in the last test. It brought to my attention again the fact that people are a little unclear about a minus on a fraction. Remember, if a minus is on a fraction, that means minus on the top only or minus on the bottom only, but not on both. That'd be positive, right? A minus in the front can't go on both. That would be positive. That's not true. Now, where people ask me about it, one of the questions on the test that asks, is this odd or even or neither? Basically, after all was said and done, the original was something like, I don't remember, x over 2x squared plus 1 or something like that. And you plugged in negative x, and you end up getting negative x over 2x squared plus 1, right? Because the negative x down here just goes away because it's squared. So then people looked at this and they looked at this, and they weren't sure whether that was odd or even. That's odd for sure. This is the negative version. Because they go, oh, no, there's only one negative. It's not also on the bottom. It's not supposed to be. A minus on a fraction, remember, goes to the top only, or the bottom only, but not both. Right? If you go to both, you've done nothing. You're back to positive, right? Everybody clear on that? That's real. Those kind of little things are what makes the difference in calculus. Fuzziness there leads to fuzziness in the big world because it's all that little stuff just blown up bigger. Does that make sense? So one more time, a negative on a fraction goes to the top only or the bottom only, but not both. So my point in this is, what do you do with this minus in front of this fraction? I would put him on the top. Well, I shouldn't cross him off. I'll just move him right up there. Why didn't I? Could I put him on the bottom? I could have, but I don't want to mess up that denominator and fiddle around with common. It's good. I don't want to mess with it anymore. So I just put it on the top. I just take that minus and put it up there on the top. Let me get rid of all this. And then just distribute that minus 9 all the way through. So what do we get? And this 6 is going to distribute 48x minus 42 minus 9x plus 81 over the 8x minus 7, x minus 9. Everybody see how we get that plus? Because that minus 9 went boom, boom. And we got a plus 8. The common mistake, the number one in the charts, is to make that a minus 81. To mess that up. Tim, did you have a comment or question?
Oh yeah, with the even or odd, I was just gonna say, or ask if the bottom was like 2x minus 1, and you had a negative on both the top and the bottom, it would be even because it's 2 negatives make it a positive?
No. Because, like, if that was the original function, you plugged in negative x.
Or something like that to where you have a negative on the top and the bottom.
All right, more complex, talk to me later if you want to talk about more complex cases on that. All right, so everybody good with how I distributed this right here? That good? Really, really, really common mistake. That kind of thing. And death to calculus students who can't do fractions. Really, really true. Please believe me in that. If you really want to go to calculus, you've got to hone your algebra skills. Like, that's got to become like the back of your hand. Never mess it up. 10 times in a row, perfect. Can't be 8 out of 10, because calculus will have it again and again and again and again. Every problem will have it, and pretty soon you'll get really discouraged. Because you know the calc, but you can't carry it out. You know? So make sure you learn it if you want to go that way. So what's that? 39x plus, was it 39?
Yeah.
That's funny. Maybe that's on purpose. All right. X minus 9 greater than 0. All right. So there we go. It's all, oh, I can factor out a 39 on the top, huh? So I guess I should take out a 39, x plus 1, well, yeah, over 8x minus 7, x minus 9 greater than 0. So there we go. There's the cleanest version of it. I'm not going to do any more. Is that okay? I just stop right there on this one. Well, I know I hate to stop. Maybe I could do a little more. Maybe I'll just do it quick without a lot. I always say that, huh? It'll all happen, and I'll do amazing things, and it'll all happen in 15 minutes. 39x plus 1. I live in a dream world about time. Just ask my wife and kids. They know. 8x minus 7, x minus 9. 7, x minus 9 greater than 0. Do I have that right? Is that what it was? Yeah, 39, that's right. So everybody got that down? Everybody see how we combine those? I'd be glad to help with that. Come by office hours or ask now even. Is everybody okay with that algebra? It's all the algebra that you really, it's the most important thing in this class, preparing you for calculus, is that kind of stuff. All right, so what do we do now? You know, numerator equals 0, denom equals 0. So the numerator equals 0, that's just negative 1, huh? Right? Only negative 1 is going to make that top 0, huh? Right, what's going to make the bottom 0? Whatever 8x minus 7 equals 0 and x minus 9, yeah, which that one's clearly 9. But then the other one also, move that over. 8x is 7 divided by 8. So 7 eighths, and 9 make the bottom 0. Negative 1 makes the top 0. So when you go to the thing here, the number line, you've got the negative 1 here, and then you've got 7 eighths, which is going to be a vertical, and you've got 9, which is going to be a vertical, because those both came out of denominators, huh? So 7 eighths and 9 are both verticals. Negative 1 is a normal x-intercept because it made the top 0. And so then you've got, what, 4 regions? Yeah. 4 regions. You know, you got, is it above or below in the first region? Is it above or below in the second? Is it above or below in the third? Is it above or below in the fourth? We got 4 sections to determine whether it's above or below. You're going to need to just plug in a bunch of points. It's going to be a little tedious because there's all these verticals everywhere. So you're just going to have to plug in some point to the right of 9, like 10. You know, plug it in. Now, actually, guys, it's easier than you might think. See, I'm wanting to do the whole thing. I'm almost, I just can't not. All right, so let me show you how it's easy. This happens in calculus. You have to do these in calculus with derivatives, where you take the top and the bottom equal to 0. All right, so let me help in preparation for that. Can you see a quick, easy way to, because, I mean, you can just use your calculator, plug 10 into the whole thing, but if you know the quick way, you can do it just by looking at it. If I want to plug 10 in, let me write it out here. Over 8x minus 7, x minus 9. If I want to plug in 10, 10, 10, Can you just do signs? Just do sign, plus or minus. Is the top plus or minus? Plus. I don't care plus what. It's just plus, right? Because 10 plus 1 is 11. That's positive times 39. Positive, positive, positive. Right? Okay, what about here? 8 times 10, 80. Minus 7 is positive. And 10 minus 9, positive. Right? So it's positive over positive times positive. So it's positive. So it's up here. The graph must be up there. Right? Graph's up here somehow. I don't know exactly how. Well, I guess it's probably doing something like that. Whatever. It's up. All I care is it's positive. It's positive off to the right. Oh, and I could have done in behavior, couldn't I? That would have worked also. Yeah, and it would have been positive. So anyway, so it's positive on the right. Now how about somewhere between 7/8 and 9? So that any number, like how about 8? Or 7 or 6 or 5 or 4, 3, 2, 1. How about 1? I could do 1. That might be even easier. I like 1. How about the number 1? That's bigger than 7/8. All right, plug in 1 to this thing. Can I just do it here? Put in a 1, put in a 1, put in a 1. The top's going to be positive, right? The bottom's going to be positive times negative. It's down here. It's negative. Did you see that? Was that too quick? See when I plug in that 1? The top is 39 times 2, positive. The bottom is 8 minus 7, positive, times 1 minus 9, negative. Positive, positive, negative, negative. See how quick that is? Do it by hand. Don't even need a calculator. All right, next part. What about when you plug in a number between -1 and 7? It's like, how about 0? That's a nice one. How about 0? Plug in 0 to this thing. Put a 0, put a 0, put a 0. What's it going to be? Can you tell me the signs? What's the top? Positive, 39 times 1, right, on the top. The bottom, 8 times 0 is 0 minus 7 is negative, and 0 minus 9 is negative. Right, the two bottoms are negative, so the whole thing is positive. It's up here. And then it hits there. Yeah, and then is -1 a pass-through or a bounce? Yeah, first power on the x plus 1 term that gave us our -1 x-intercept. First power, it's a pass-through. It's odd. Passes through. It's got to be down there. All right, what was the question? Where is it greater than 0? Where is it above? It's above here, which means this section of the x-axis. It's above here, which means this section of the x-axis. So from -1, oops, I just blew it up there. From -1, because I want to show you that. I always see something and flashes in my mind the mistakes I've seen over the years. Don't do this. So first step, you got to get 0. Jump this guy. Don't jump them. I was just grading the test, and I remember some people doing that. You always want the front term to be positive. That's just easier to factor, where the front term is positive. So dot, dot, dot from there, right? Factor it and do your thing from there. But always jump it so the front term, rather than jumping everything to the right, you can go right or left. Sometimes I go right, sometimes I go left. I go wherever the front term is going to be positive, because that's easier factoring. All right. So, all right, so I'm going to say for what positive? 2 times the cube, 2x cubed, exceed greater than 6 times the square. Make sense? And they said for what? Positive numbers. Only x greater than 0. Realize they're limiting the field of play. Only positive x's because they said so. Right? So ignore, when you do your x-axis, don't go left to 0. No fly zone. Right? They said so. Only what positive numbers make this happen? Right? So solve this thing, but ignore anything left of 0 because they said so. Okay? Yeah. So what do we do with domain when they have a root? Domain, remember, domain is what's allowed, what's not allowed. So what's not allowed inside of a root? What can you not be inside of a root? Can't be negative, so you got to be greater than or equal to 0, huh? So dot, 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 right? Factor it, and off you go. It's a tricky way of giving you another greater than less than question, basically. See how they're trying to be, ooh, they're tricky. They're just doing it another way. It ends up being a greater than less than question. Right? Because that's what domain means. Inside of a root, greater than or equal to 0. Afraid of, there's word problems at the end here. All right, so you know when a bar is on something like that, that means average. So, and they're saying the word also, average cost. So anyway, so they want that average cost, 50x plus 4,200 over x. They want it to be what? No more. What is no more? If something's not more, what is it? Less than or equal to 120. It's no more. It's not more, so it's less or equal, right? So they're basically giving you an inequality. Dot, 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 right? First step, get us there. You're going to have to combine the two fractions into one. All the same stuff, right? On that. All right, so in a bungee jump, amount of cord that will stretch to the bottom of the fall. Okay, stiffness, da da da. Use the equation. Okay, so a 110-pound person plans to jump off a ledge attached to a cord of length 42 feet. Free length of cord, okay. If the stiffness of the cord is no less than 24 pounds per foot, how much will the cord stretch? Okay, so what's the stiffness? Looking at the words here, K is the stiffness. See that? I'm just matching up words with words. They said stiffness no less than 24. And this says K is stiffness. So K, which is 2WS plus L, there's an L there, over S squared is no less. What's that mean? No less. Greater than or equal to. If it's not less, then it's greater or equal. No less than 24. Isn't that what they're saying? And they're giving me the L is 42. So 2W S plus 42 over S squared greater than or equal to 24, huh? What's the W? Oh, that's the weight, 110. So I should put that in there also, yeah. 110. There. So now we're down to one letter, inequality, solve it from there. Does that make sense? See how it's regular in the end? Well, there we go, sort of. It's the best I can do with our 50 minutes. All right, guys, this is due next time. I'm sure it's more than an hour.